Good morning to all. I'm Sumitra, working as an associate professor in Triple Department of Engineering College. And this semester, I'm handling renewable energy system for seventh semester Triple students. Now, in this video, I'm going to explain about the solar radiation and the solar radiation measuring devices. So, let me give a brief intro about the topics which is coming in third unit. So in third unit, we have the concepts which are getting related with the solar PV systems and the thermal system. And under that, we have a solar radiation measurement, and solar thermal power plant. So now in this video, I'm going to concentrate about the solar radiation and the radiation measurement devices. So now coming to the introduction, let me give a brief intro about the solar energy. We all know that energy can be produced and radiated by the sun in the form of solar energy only, and that too, the energy is radiated in the form of electromagnetic waves by the sun, and the electromagnetic waves are getting categorized into different radiations based on the wavelength it has been propagated. So energy which is having a wavelength, the radiation which is having a wavelength less than 0.39 micrometer is known as ultraviolet radiation, which is of about 8% of the energy which is reaching the top of the earth atmosphere from the sun. And then the radiation which is having a wavelength between 0.39 to 0.78 micrometer is of visible light, and which is of about 46% of the entire thing. And then wavelength radiations of wavelength more than 0.78 micrometer is termed as infrared radiation, of about 46% of the total energy from the sun that is reaching on the earth atmosphere. And now, regarding the solar radiation, there exist two different types of radiation, namely the extraterrestrial solar radiation and the terrestrial solar radiation. So, what is the main difference between the two radiations and all? Both the things are going to come from the sun only, and they are supposed to reach the Earth atmosphere. But the extraterrestrial is the one in which the radiation getting incident on the outer atmosphere of the Earth. So, based on this radiation, we have a constant called the solar constant. On an average, the extraterrestrial irradiance level is measured as about 1,367 watts per meter square, which is also known as one solar constant. And then regarding the terrestrial solar radiation, this is the radiation that reaches the Earth's surface after passing through the Earth atmosphere, and that is, it has been deflected by means of the what to say impurities present in the earth, and by me after getting deflected from those impurities it will reach some earth surface. No, that is known as terrestrial solar radiation. Always the terrestrial solar radiation is less than that of the extraterrestrial solar radiation. Why means the reduction is mainly due to the atmospheric absorption and scattering, like a reflection in earth. And now this diagram will clearly shows you the extraterrestrial radiation and the terrestrial radiation, where the extraterrestrial is the one which reaches the atmosphere, that is the Earth atmosphere, top of the Earth atmosphere, whereas the terrestrial is the one where the radiation after reaching the atmosphere, it has been reflected by means of absorption and the things which is present in the atmosphere like dust, oxygen, carbon dioxide, etc. These are the terrestrial radiation. Okay. Next, we can also define the solar radiation composed of two different components, namely the direct or the beam radiation, and the second one is diffuse radiation. So the direct or the beam radiation is the one in which that the radiation reaches the earth without any change in its direction. That is, directly from the sun, it reaches the earth's surface without having any deviation in its direction of flow. Whereas the diffuse radiation is the one in which there is a change in the direction because of the particles present in the atmosphere. That is, by means of scattering and reflection, this diffuse radiation will occur. And we have one more term called the total radiation or the global radiation, which is nothing but the sum of diffuse radiation and the beam radiation. So now, already I told you, extraterrestrial irradiance can also be measured in terms of a solar constant, which is nothing but the rate at which the solar energy arrives at the top of the atmosphere, right? So this is the, or you can also define it in some other way, like it is amount of energy that received in a unit time on a unit area perpendicular to the sun's direction at the mean distance of Earth from the sun. Here we have one formula for calculating this also in terms of extraterrestrial radiation, like IEXT is equal to ISC into RAVB R the whole square watts per meter, where X is the extraterrestrial radiation and ISC is the solar constant, which is of about 1367 watts per meter square, and RAV is the mean distance between the sun and the earth, and R is the actual sun-earth distance. Next, we have some basic sun-earth related angles like latitude angle, and then declination angle, inclination angle, zenith angle, solar azimuthal angle, and hour angle. And these angles are going to give some data regarding the relation between the incidence of the solar radiation on the Earth. And these might be coming in part A questions. Then coming to the measurement of the solar radiation, here we have certain devices or the instruments which is meant for measuring solar radiation together, or specifically it is to measure the diffuse radiation or the beam radiation like that. So here we have a type of measuring device called a pyranometer, which is meant to measure global or the diffuse radiation, like Eppley pyranometer, Elliott solarimeter, mole pyranometer, bimetallic pyranograph, etc. And the same one more device is existing to measure the beam or the direct radiation, like pyrheliometer, disc pyrheliometer, Eppley pyrheliometer. So let me explain about what is a pyrheliometer first. It is, as I mentioned earlier, it is used to measure the total solar radiation, and even we can also able to measure the diffuse radiation alone, since we know that the global solar radiation is the sum of the direct radiation and the diffuse radiation. Even with the same pyranometer, we can able to measure the diffuse radiation just by means of inserting a shading ring. So how means the shading ring, which I am going to include in the pyranometer construction, will prevent the falling of the beam radiation into the sensor provided for measuring the radiation. So it has a sensor which has horizontal radiation sensing surface, so which is going to observe the solar radiation energy from the whole sky and transform that energy into the heat. So the global solar radiation can be calculated by measuring this heat energy. So actually, it is nothing but a set of thermopiles or thermocouples which are connected in series, and it has two concentric silver rings, and which is going to act like a sensing element, where the inner ring is coated with the black color, which is a good observant of heat energy, and the outer ring is coated with white magnesium oxide. And the whole assembly is sealed inside a spherical lamp bulb, of which is of about 76 millimeter diameter and thickness 0.6 millimeter. So it is based on the principle of changing temperature between the two surfaces of the sensing element, that is namely the black surface and the white surface. Due to the temperature difference, we all know that an EMF will be getting produced, and this EMF will be equivalent to the amount of the solar radiation generated. So this is the diagrammatic represent for that. This is a sensing element, where the inner element is coated with the black surface and the outer one is by means of the silver one. So whenever sun falls over that, this sensing element will measure the thing, and due to the temperature difference, it will experience an EMF. That EMF will give you the equivalent amount of solar energy received. And this pyranometer finds its application in meteorology, climatology, solar energy studies, and even in building physics also. And then coming to the next device called pyrheliometer, which is meant for measuring the beam or the direct radiation. And again, here we have a sensor which has been placed at the center, that is at the base of a tube. And so this is the diagram for pyrheliometer, and this is a sensing element which is placed at the base of the tube. So the sensing element is made up of silver disc, which is of about 28 millimeter diameter and thickness 7 meter. The disc is painted in black on its radiation receiving side, and also it has a hole to allow the bulb or thermometer to be getting inserted. And to maintain the good contact between the disc and the bulb, the hole is filled with a small amount of mercury. And how it is working means, and during the measurement phase, the disk is heated by the solar. Whenever the sun's heat falls on the disk is getting heated by the solar radiation, and obviously temperature rises. And the intensity of the radiation is measured by means of the temperature range of the disk. So this is how the thing is getting developed. So thank you all.